Goes the recording.
Well,
Okay,
we should have asked if they wanted to ask anything off the record first.
anything off the record?
Nothing off the record. We'll ask all our questions totally on the record.
Right.
We could always censor it, just, put in bleeps.
So anyway, we're gonna go off into this intersection of mysticism and science tonight. So there's going to be two different pieces. One is on what's called synchronicity, which we'll get into. And so that's based on discussions between Carl Jung and Wolfgang Pauli. So Pauli was this incredible physicist who was taken aback by in the 1920s, the physicists put together this whole notion of how mechanics are in the very small. So they called it quantum mechanics for discrete mechanics, the mechanics of atoms, discrete entities. And the problem that came up, we saw, was way back at the beginning, we did this double slit experiment movie. So in the double slit experiment, if you are dealing in the classical world, the world that we live in, and you shoot balls through a slit, they go through the slit and they all line up on the other side of the slit. And if you have two slits, you shoot the balls through the two slits and they all line up on the other side of the slits, and that's it. But in the quantum world, when you take electrons and shoot them through the single slit, you get them to all line up. When you have two slits, you end up with an interference pattern where the electron is turned into a wave. And that was very disturbing to someone like Pauli, who's a great theoretical physicist, because how in the world do you explain this? The electron is both a particle and a wave. So he spent time with Jung trying to delve into these things. And that resulted in this book called Atom and Archetype, which we'll touch on. So we have quantum mechanics, and here the thing to keep in mind, we'll show this, is the observations that Ron Cowan did are critical in showing why the double slit experiment works the way it does. That in fact, there's blocks of information that are coding everything, all the electrons and all the walls of the compartments of space, and they're always scanning everything around it. And so they immediately detect, is there one slit or two slits? And to the two slits, then it says I'm going to behave as a wave. Now, this is you'd have to ask yourself, who made the rules of the game? Okay, or as the physicist Richard Feynman said, well, we have all these things we know, and all the things that we don't know, we say those are due to God. Okay, so here you have an example of this information scanning that Ron saw that encompasses everything. Jung would call this the collective unconscious everywhere, that's what's controlling the rules of the game and so forth. Maybe that is God, who knows, when we figure it out. So that'll be the first part.
Okay, the first question though, didn't that slit experiment also have something to do with if there's somebody watching, it changes the behavior?
That's part of the experiment. Then if someone's watching, then that immediately means that it has to behave like an electron, because that's what it is. It's an electron. If you're not watching, it behaves like a wave.
So it's just the actual observance.
Yeah.
Not the fact that it's two slits, it's the observance that changes.
It's the system is expanded from a single electron going through two slits to an observer and a single electron going through two slits. It could be a
mechanical observer. It doesn't.
Yeah, it could be a camera. Okay, could be a robot sitting there looking. That's enough to throw it off.
Yeah, I never understood it. I still don't understand it, but okay.
Well, there's nothing to understand.
Getting it clear what the problem is.
These are, right. And this is what this
there is no understanding it with our current.
We touched on this with this physicist David Bohm. Bohm talked about the implicate order and the explicate order, And the
Jesse.
double slit experiment is an example of the implicate order with things behaving the way they do, because we don't know why they do. How could it possibly become an electron and become a particle and a wave by just changing the number of slits? But that was what Bohm dealt with. So that's part of it. That's why quantum mechanics is viewed as an incomplete theory. Ron's observations went a long way toward making it more complete by showing that this information is in fact in there algorithmically governing things, but that just raises the level of confusion to a higher level.
I was gonna say.
Our ignorance is
Well,
that much
At,
greater.
at least you make me feel better by saying that it's general confusion and it's not just,
Right.
me
No,
going,
no.
I don't get this. I never have.
No,
It
there's
can't
nothing
be
to get. It's the way the world works. I'm not defending this. I didn't make these rules up. It's for whatever reason the world decided to work this way.
What it
So-
shows is our understanding of the world is completely incomplete.
Okay. Now there's a second theory that was developed by Einstein in the 1915-16 timeframe called general relativity. And unlike quantum mechanics dealing with the very small, this dealt with the very large. So he was dealing with gravitation and how matter would curve space. The more dense matter was, the greater the curvature of space. And this led to effects such as when you get into a gravitational field that gets stronger and stronger, time slows down. Time slows down, okay? Which is bizarre. Like, what is going on here, okay? And when you drop into a black hole, which is the ultimate in terms of gravitational attraction, one wonders, time might slow down so much that you might never make it there. It might be going so slow for you that as far as you're concerned, it's forever. End of story. So this theory, general relativity, dealt with things on the very large, with galaxies and stars and things like this, not with things on the very small. And the thing to keep in mind here is that this theory has never been turned into a quantum theory. That is a theory. How would this behave if we went down to the very small? Well, again, Ron Cowan looked at this and he saw that space itself is made up of these compartments, and the compartments, which are very small, obviously, are coded with information that controls everything. And so that is the linkage between the two. But modern science, of course, doesn't acknowledge this because they don't acknowledge what Ron observed. You're sitting there doing this in deep meditation, and they go, "So what? Show me a meter. Show me a photograph." And he's doing sketches with his paper and pencil. That doesn't count. Okay, I don't know why it doesn't count, but it doesn't count. So you have these two inconsistent theories, and the theory of general relativity was actually used, and we're going to go through this in World War II. A number of people, including Einstein, but also Nikola Tesla, and you'll see the others, were looking for a way to make ships invisible so that the Nazi subs couldn't see the ships that would be carrying all of these supplies back and forth across the oceans. And so they worked on this, and you'll see something called the Philadelphia experiment. The Philadelphia experiment occurred in Philadelphia in 1943. Of course, it's not acknowledged to have ever happened, but it happened, okay? And the net of it was that in terms of trying to make a ship invisible, it succeeded very well. The only problem was it shifted the ship in space and time 200 miles away, and then it shifted it back, okay? And we'll see what happens in there. So the takeaway from this is we're going to be dealing with the notions of time tonight. And the fact is we have two inconsistent theories here, quantum mechanics and general relativity. They don't tie into one another, but they each offer predictions of how the world works. And they both do very well, but no one's been able to tie them together other than what Ron has done in terms of his observations. So with that, do you want to, it says you have to plug in.
Yeah. I'm running out of juice. I'll be here. I might have.
The battery.
Yes.
We just had that happen here at home.
Yeah, Marjorie.
Just keep going. I can hear you. I'm just gonna have to relocate it.
Okay. So do you want to run through? There's a little thing we've got here on the marginalian, which we'll share with everyone. Let's hold on a second. Here it is.
By way of introduction.
So this is the book that came out between Jung and Pauli was called Atom and Archetype, and they corresponded together. They met, but they corresponded about 80 odd letters between 1930 and 1957. Pauli died in 1958. Jung died in 1961. So this is an attempt here where Pauli is talking to Jung, saying that what's going on here is really bizarre. Do you have any idea of how in the world to explain this? And the outcome of this was this notion of synchronicity. Is there anything you want to cover on this?
Well, why don't you keep going? Share it, read it.
Well, every true theorist is a kind of tamed metaphysicist, Einstein wrote. He was probably thinking about Pauli, who postulated this particle called a neutrino, which was a very small particle, like a neutron. It had no charge, so it was an itty bitty neutron, so he called it a neutrino. But the main thing Pauli was known for was his exclusion principle, that when we deal with things, for example, in the hydrogen atom, we have one electron that circles the nucleus of the hydrogen atom. When we get two hydrogen atoms together to get hydrogen gas, the end result is we have two electrons, but they're each in a separate state. And the physicists decided to call this spin. So one has an upspin and one has a downspin. But the point is they're in two different unique states. And Pauli said that this is an exclusion principle. If you try and put two upspin electrons into a hydrogen molecule, that is with two nuclei of hydrogen, one of them will get flipped out, one of the electrons, and turn into a downspin as opposed to an upspin, because you can't have them in the same state. And again, no one knows why that is. It's just how things behave, and that has been a very powerful principle that led to all of the advances that you see in particle physicists. So Pauli wrote a critique of Einstein's theories, and he did this at age 21. And Einstein said, after Einstein read this, he said, no one's studying what Pauli wrote could believe that this is someone who's 21 years old. What to admire most, the psychological understanding of the development of the ideas, the sureness of the mathematical deduction, the profound physical insight, the capacity for lucid systematic presentation, the complete treatment of the subject matter, or the sureness of critical appraisal. So Pauli himself didn't really write that many papers, but for example, Werner Heisenberg, who was a colleague of Pauli, gave all of his draft papers to Pauli to critique. And Pauli would scrub these things like there was no tomorrow. And the end result was what Heisenberg published was far better papers. That was who Pauli was. And here we have a picture of Jung and Pauli. And they went at it and doing all this stuff, and we're going to run through this. Jung wrote at the end, we don't know whether what we on the empirical plane regard as physical may not, in the unknown beyond our experience, be identical with what on this side of the border we distinguish from the physical as psychic. We know from experience that psychic processes are related to material ones. We're not in a position to say what this relationship consists of, how it is possible at all, but there's some sort of linkage here between things that are quote unquote physical and things that are psychic. And this you'll see here with Pauli's.
I thought he means psychological, not like
Yeah.
a woman with horn twinkly glasses.
So, I'm gonna. We're gonna include this in we send out the recording, but I'm gonna get out of this now. Let's see if I can get us into.
But it shows we're not the only people interested in it.
Okay, can everybody see this?
Yep.
Okay. So here we have Pauli Jung, and this is from the I Ching. These are the 64 possible hexagrams you can come up with. So synchronicity. Jung introduced this to describe circumstances that appear meaningful, relating, but lack a causal connection. And we'll see what the example of this is in a second. And so you have things that are synchronistic. They don't seem to have any causal relationship, and yet they somehow are connected. So Jung developed this theory after meeting with Pauli, and Jung had different definitions. Remember, they're collaborating for over 27 years, from 1930 to 1957. So this is some sort of hypothetical factor that's equal in rank to causality for explaining things, or it's an acausal connecting principle, or it's an acausal parallelism, or a meaningful coincidence of two or more events. And Pauli said, well, these were corrections to chance fluctuations by meaningful and purposeful coincidences. So if we could dig into this, we might have a much deeper understanding of how the world works and understand these acausal connections, okay? In 2016, 2/3 of all therapists agreed that synchronicity could be useful. These are analytical psychologists that hold to this. There are different examples of this along the way. Let me just skip ahead here. Oh, yeah, I forgot about this. Arthur Kessler wrote a book in 1972, which is worth reading, called The Roots of Coincidence, and has many examples in there of things that are coincident, but you can't figure out how in the world are they causally connected. A given observer may subjectively experience a coincidence as meaningful, but this alone doesn't prove anything objective. You have all kinds of statistical laws, how unexpected occurrences can be inevitable or more likely to be encountered than people otherwise assume. But some of the things we're going to deal with here in synchronicity are, really off the charts. There's nothing, statistics don't begin to do it justice. So Jung was using the I Ching. He was reading it. He had 64 hexagrams, and that you would make a divination here, which would seemingly be random. His translator, Richard Wilhelm, who took the Chinese and translated it into German, met with Jung, and they went through a whole discussion in 1923 on this, and Jung was so taken up with this that he just jumped all over it, thought it was just incredible.
Well, then Wilhelm invited him to write the forward to the
Right.
first English translation.
So Jung coined the term synchronicity in a lecture in 1930, but he was probably using it before that, 1928. And Wilhelm died in 1930. And so what Jung stated at the memorial address, that the science of the I Ching is based not on the causality principle, but on one which is hitherto unnamed, because it's not familiar to us. And I've tentatively called this the synchronistic principle. So it could be that this is what instigated Pauli to get together with Jung. The I Ching, again, is a part of Confucianism. You end up having these yarrow stalks, and you toss these things, or you can toss coins. You don't need to use yarrow stalks. But the net of it was you end up with readings, and this would perhaps suggest trends or things that you should focus on. Jung argued that Chinese philosophy included this, and it also included in the Tao these concepts. There were some German philosophers like Leibniz, whose exposure to the I Ching in the 17th century was the real precursor to the theory of synchronicity in the West. And Schopenhauer, who Jung placed alongside Leibniz as the two most influential philosophers in the formulation of the concept of synchronicity, along with Kepler, you end up with two fundamentally different kinds of connections. First, in the objective and causal connection of the natural process, and secondly, in a subjective connection, which exists only in relation to the individual who experiences it, which is thus as subjective as his own dreams. So, pretty heavy duty stuff.
So Bart,
Yeah.
Is that saying at a very simplistic level that synchronicity, that things that are a coincidence, if there is a principle operating, it's happening more often than would be predicted by pure statistics?
Yeah. We're going to use examples, so you'll see these things are very concrete, and forget statistics. Just judge for yourself when you look at these examples. We haven't got to them yet. there's a lot of other work prior to what Jung and Pauli were doing. I'm just looking to see. In quantum mechanics, there is the notion of entangling the states of a quantum system of and this is what is the basis for quantum computers is quantum entanglement. And this does indeed lead to a particular type of acausal quantum correlation. Pauli took this to be a model for the relationship between the mind and matter that he proposed along with Jung.
One of the key components of synchronicity is it has to be meaningful.
Right.
The coincidence.
Is it also because like types of waves tend to get into sync with each other? That wave motion, does it have to do with wave motion?
No, the notion in quantum mechanics of a wave is different than it's the way it's unfortunate. The equation that describes it is a wave equation. That much is okay, but by no stretch of the imagination is it a wave. I take the square of the magnitude of the wave function, and that gives me a likelihood, a probability that it'll be doing this, that, or the other thing. Okay, so it's very probabilistic at its very foundations. It's not any sort of physical wave, but it happens to solve to come out of a wave equation, which of course confuses everything.
Yeah, okay.
It's a good question.
You got that part, did you?
Yeah. You know, one thing we can do is I'll put in here some things on entanglement, just so we'll have that as complete here. Jung ended up dealing with this in the psyche. What I'm looking for here is I'll just give it to you orally here. Jung had a particularly difficult client. He had a lot of difficulty in trying to come to grips with what the issue was with what this client was going through. It was a woman, and he was she had a dream where there was a scarab.
Yep.
That was running around. Okay,
Flying around.
Flying around. And just as she's telling this to Jung, and Jung's in his office with her.
In Switzerland.
Yeah, he hears a tapping on the window, and he looks up, and there's a scarab outside pounding on the window, trying to get through the window. And so he notes this and tells it to the woman, and immediately
he went and he grabbed it, and
right.
he handed it to her.
And this was the breakthrough where, from that point on, she was able to come to grips with her issues that she was dealing with here. And so that was an example of forget the statistics that are there. What's the likelihood of her telling him, I had this dream, and at the same time, the scarab pounding on the window outside trying to get in? I would argue it's like highly unlikely that it happened.
And it just unraveled her resistance. She was very rationalistic, and kind of, he would say, animus dominated with this rationalism, and that all kind of broke apart with this moment of the scarab.
Right.
It's a good thing.
Pauli didn't like the notion of Jung using astrology. It's clear that Jung kept charts as natal charts on every one of his clients, and he taught himself. He undoubtedly, just by the sheer power of his intellect, was a very accomplished astrologer. but this bothered Pauli because he couldn't figure out what was going on. But the astrology side of things, this is what I've argued with Marjorie, is that these different entities that you deal with in astrology, the sun, the moon, the different planets, that there's archetypes there which are very complicated, and we get influenced by them as they get nearer or farther away. And that's how I view this as being, you know, a meaningful activity. But who knows what it is? I'm just giving you my 2 cents on what's going on. One of the things that drove all this was Pauli's experiences. So Pauli was a great theoretical physicist, but he was a terrible experimental physicist. And the experimental physicists wanted to impress Pauli with the experiments in their lab. So he would always get these invitations to come to this lab and that lab and look at what they were doing. And when he went into any of these labs again and again and again, he would walk in and the experiment that was there that was working perfectly okay would immediately fail, okay? It would just, things would break in front of your eyes, okay? It was like impossible. What in the world is going on here? And the most well-known example of this, let's see if we've got it in here. Here's the scarab example of Jung here. Here's a different example of, this is a French writer who was treated as some plum pudding by a stranger named Monsieur de Fontgibaud. And 10 years later, he found plum pudding on the menu in a Paris restaurant, ordered some, but the waiter told him the last dish had already been served to another customer. Turned out to be de Fontgibaud. And then many years later, he was at dinner and once again ordered plum pudding. He recalled his earlier incident, told his friends that only de Fontgibaud was missing to make the setting complete. And in that same instant, the now senile de Fontgibaud entered the room, having gone to the wrong address. So, you know, how can you explain this? Okay. The example that's here with Pauli that everyone knows about is there was a great physicist in Göttingen, Germany, Frank, and he had a very complicated experimental in his lab. And one afternoon, without cause, the whole thing just collapsed. And of course, Pauli is in Zurich. And so Frank wrote to Pauli at Zurich and said, you know, you'll never believe what happened. My experiment collapsed. And Pauli wrote back that, oh, by the way, I'd taken the train to Denmark, to Copenhagen, and actually in the time that your experiment collapsed, the train actually stopped at the Göttingen train station. Okay. And the times lined up. And so this is what is the so-called Pauli effect, or this is the nature of synchronicity. You know, how could these things be linked together? The thing to keep in mind, or this is what, you know, Ron observed was, and the other thing to keep in mind is, remember, all of this ignores the fact that the physics we're talking about was only dealing with 5% of the mass and energy in the universe. The other 95% is dark. It's either dark matter or dark energy. And Ron, in fact, observed all of these things here in doing that. But the thing to keep in mind is it might be that these other dimensions are what is being used to go link these things. One of the things that's crazy here is the natural coordinates for space and time in our space are X, Y, Z for the 3 spatial dimensions, and then time I have a little footnote down here, is actually ICT. So I is the square root of -1, C is the speed of light, and T is time. So time, which is in seconds, multiplied by the speed of light, which is meters per second. Now I have something which is a length. Okay, the problem with this is the time is in seconds and the other dimensions are in meters. So by doing this, it converts everything to meters with one little kicker, that it's been multiplied by the square root of -1. And the thing to keep in mind here is apparently by multiplying by the square root of -1, you actually take this dimension that we call time and rotate it by 90 degrees away from the other three spatial dimensions. Well, how could you possibly rotate something 90 degrees when these three dimensions are all perpendicular to one another? That's why this is called the fourth dimension, but it's somehow perpendicular to everything. And the rotation by 90 degrees comes about because the square root of -1 just happens to be equal to the exponentiation of pi, the number 3.14, et cetera, over 2 times I, the square root of -1. And this actually, pi over 2 is 90 degrees, if you remember anything from high school geometry. So this is the leap of logic here, is the time is actually another dimension, but it's been rotated by 90 degrees from the three dimensions that we deal with here. So having said that, things got a little worse.
Oh, thank you.
We go back over here. If these are the dimensions that we're in, then it looks like this dark matter that Ron observed is perpendicular. It's in a four-dimensional space that's rotated by 90 degrees in total. I get the rotation 90 degrees by multiplying by the square root of -1. So that means if I do that, I take square root of -1 times these things. I got Ix, Iy, Iz, but then multiplying I times I times I is the square root of -1 squared. So it's -1 times CT. So apparently we end up with the dimension of time showing up in our space over there, even though it looks like it's over there. So these are the things that come out of just turning the crank here. You start to talk to yourself and say, I really don't know what's going on here. So that's what I wanted to cover on the synchronicity side. Now we're going to go to.
Well, are there any questions?
Yeah, we'll stop for questions.
She asked facetiously.
Well, I'll put in something on quantum entanglement so that we'll have something on that because that is spooky by itself. But there's many experiments that show quantum entanglement exists, and it is the basis for quantum computers.
I don't even know how you could begin to ask a question about that. Bruce, do you have a question?
I don't have a question, but I do have an experience. I mean, there's levels of awareness that I've experienced where, I mean, these flashes of insight and deeper dimensions of insight don't last very long, but you see things very differently. And one of the observations is that when you, in a very deeper level of the reality mind, nothing is separate anywhere. Like it's sort of beyond normal observation in terms of the thinking the outer is the only reality. In terms of the awareness, there's actually much deeper levels of awareness.
Right.
And that's where I find that everything is not separate at all. Everything is already in union already. So the fact that we think everything's separate from that level of awareness is an illusion.
So the sort of theological concept of oneness or unity kind of lines up with this concept of synchronicity.
Well, synchronicity is straightforward simply because everything's not separate in the first place.
Yeah, it's a piece of the story. The thing that I've noticed in my dreams over the years is I'll see something in a dream. I'll wake up and remember that little piece of the dream, and it'll be me, you know, someplace in a grocery store or you know, in a park somewhere talking to someone, and 2 or 3 days later it'll happen. So somehow I'm skipping forward in time, and there's no rhyme or reason to what these things are, and I'm doing it when I'm deeply asleep.
Well, that's what's confusing about it, is that it feels confusing and not rational. But in terms of a deeper level of awareness, it all makes sense. So
Right.
it's, yeah.
Well, yeah, the thing to keep in mind here is that there's really 24 spatial dimensions and 2 time dimensions in that 26-dimensional picture. Time is really different than the other 24 spatial dimensions. So that's what you have to always keep in mind. Time is, you know, time has its own thing that we fool ourselves into thinking that we know what time is.
And that it's linear.
Yeah, just because you have something called a clock and it goes ticking, that isn't time. That's the clock ticking. That's nothing. That's the clock is along for the ride. But time is something entirely different.
How you doing there, kiddo?
When we get to the time dimensions, whenever we have a conversation about stuff like this is where I get lost.
Well, everybody gets lost. This is the mystic side of things that we're trying to expose you to, but we're not saying we understand this. I'm just trying to show you there's examples floating around that show, you know, the net of it is the takeaway is time is different. Okay, that's what you should keep in mind.
And that it's our conventions around it that are the problem.
This looks too bright. You guys are staring at this light.
It's our concepts. It's not. Our concepts are unrealistic oversimplifications, and whatever's going on is more, I think, fluid, but.
Yeah, and this is not to say we're going to cover what that is in this class. Okay. There's going to be another class, but it won't be this one. So here, let's look at what's called the Philadelphia experiment. And you have a picture here of what's called the destroyer escort. This is a ship that carries probably 150 sailors and goes with the destroyers and is on the lookout for things like mines that are floating around. They're going to do everybody in. It also has some anti-aircraft guns on it. So the particular ship we're going to be looking at had actually 201 enlisted men and 15 officers, and it was about 300 feet long. And it could do 21 knots. So the thing about this ship is it actually has an electric generator in it that can generate 4.5 megawatts of power. And so the question came up, what could they do with this electric power generator? So surprise, surprise, in the you know, after World War I, Nikola Tesla was thinking about this, and he said, you know, I bet I know a way to make the ship invisible. Don't tell me how Tesla came up with this idea. I have no idea where he got this from, but he started pursuing it, and it culminated in this experiment done on this ship where they ended up taking heavy duty wire, 1-inch in diameter cable, and run it all the way around the ship multiple times, okay? And then they ended up hooking it up to this 4.5 megawatt generator here. And the whole thing was called Project Rainbow, so which was the code name for this, and it was meant to cloak the ship so that the ship would become quote unquote invisible. So they hooked it all up. This is just a background on Tesla. The Tesla, the thing that grabbed Tesla's mind here was that these ships are all steel. So he wanted to figure out some way to make it look as though there wasn't any steel there. And so suppose you erect a big helix or a coil here, it wouldn't interfere, the ship's hull wouldn't interfere with this coil, and you would connect it to a very high frequency, very high power electric generator, and maybe the ship, even though it's iron, wouldn't look to be iron. Now, the reason why this is important is that the German mines that they scattered all through the oceans, they all were looking for detecting the presence of iron, and in particular any sort of chance that the ship was at all magnetic. Typically, when you build things out of steel like this, they can end up with some latent magnetism in them, and the mine gets attracted to it and hits the ship, and kaboom, the ship is gone. So this is what was in the back of Tesla's mind. There was also another individual in this, Vannevar Bush, who was at MIT and worked on this during World War I and all in between World War I and World War II. And Vannevar Bush was Franklin Roosevelt's right-hand person. He was in charge of all of the scientific activities going on in World War II. So in particular, the Manhattan Project for doing the atomic bomb, what was under Bush, he controlled it. The MIT had a radiation lab, which was a cover because it was electromagnetic radiation. People thought it was atomic radiation, but it was where radar, sonar, and LORAN is a type of radio location system. All of that came out of the MIT radiation lab. And Bush was integral in getting all this stuff done. So the thing that Tesla said was the ship has to have enough electric power, and this ship has 10 to 15,000 horsepower. So you could end up with, basically 4.5 megawatts of electric power, and that would be enough to go drive the coils around the ship. Now, there's a precursor to this. In 1892, Tesla took a steel egg. He called it the egg of Columbus, and the reason he called it that was that in 1892, that's the 400th anniversary of Columbus landing in 1492. So there was a so-called Columbian Exposition in Chicago, and Tesla was there with Westinghouse, and they put in all of the electric lights that were all throughout the grounds there. There weren't any electric lights like this, okay? Everyone was like in awe over this is what the future is going to be like. So Tesla had wired the whole thing up, but Tesla had actually put together a steel egg. And when he started to hit it with an electromagnetic energy back in 1887, no less, and pulsing things, then this egg started to spin and started to stand up on its end, okay? And everyone was staring at this going, what the hell is going on? But it was Tesla saying, well, I think there's something here. Let me keep playing with this, okay? So what this led to was in order to get rid of the magnetic fields on these ships, they would try and get rid of it by wrapping these coils around them, and this was called degaussing, for getting rid of the magnetic fields. By the way, Tesla was probably the first one to come up with the notion of radar. He ended up looking at how to do different things, and could end up discovering the relationship between the position and speed and course of any sort of moving object. And this is in 1900, okay? Go figure. It wasn't until World War II that these ideas really got into, all the things that were there in World War II. But the word radar means ranging and something like that. The Nazi mines again would detect the increase in the magnetic field of the ship, because the Earth's magnetic field, the ship's moving, that's going to generate a current or a magnetic field in the ship, and that's going to attract this mine here. And so if you're in the northern hemisphere, it'll point up. If you're in the southern hemisphere, it'll point down, but it's still the same thing. There's still some magnetic field there, and the German mines would get attracted. So by putting these cables around the ships, and they did this for like 10,000 ships. This is not a minor thing, okay? Then the magnetic field disappeared, and they didn't know what to call this, but the unit of magnetism is in honor of Gauss, the German mathematician who also did a telegraph, no less, at Göttingen in the 1830s. And so not knowing what to call it, they said it's degaussing. It's getting rid of the magnetic field. And so this is absolutely standard practice. And we get into the middle 1943 timeframe. Every ship in sight is being degaussed to make sure the Nazi mines don't hit them. So what in the world is going on here? Well, this ship was moored in the Philadelphia Naval Yard. It had these cables around it, and it had these power generators, okay? And there was a controller that apparently Tesla had come up with. And when things started going, the ship, and remember there's 200 people on this ship, okay? The ship disappeared. And then it reappeared, okay? Now, one of the problems is when the ship disappeared, it apparently appeared not in Philadelphia when it disappeared. It appeared in Norfolk, Virginia, in the naval yard there. And everyone in Norfolk saw the ship. But the problem was this happened 20 minutes before they turned on the power in Philadelphia. 20 minutes before this happened, okay? Well, of course, all of this is from eyewitnesses who saw this.
What?
And of course, the U.S. Navy denies that this ever occurred. There's also a report that the shipyards in Germany, in Kiel, had a similar type of thing happen. The Germans are no idiots in terms of doing this sort of stuff. And they had a ship disappear. So who in the world was involved in this? Well, Einstein was there looking at what's going on. John von Neumann, who was, colleague of Einstein, was heavily involved. Von Neumann's thesis advisor, David Hilbert, you know, knew of what was going on. Tesla clearly knew what was going on. He died before this actually happened. There were other people like Bertrand Russell, Vannevar Bush, Gabriel Cron, who had a very distinguished career at General Electric, designing electric motors. He knew what was going on, and so forth. So these are a bunch of heavyweights. This is not, this is the first team that's in there looking at what's going on here. This is a picture of what appears to be Tesla's controller. It's interesting that the individual that got this was heavily into the black ops side of things. So this is not something you could get readily. And the thing that was interesting to me about this was it has no on-off switch. Tesla built into it some way for this thing to be powered, but there's no cord to it. Okay, and it is indeed still running today. Okay, as we sit here today, this is still working. Okay. So what in the world did people see? What did these eyewitnesses see? Well, the ship disappeared and then vanished, came back again. But there was a green fog, okay? There was a green fog around the ship when they cranked it up. And this led one of the people here to be in a very confused state. When they looked through the green fog and the green fog cleared up, he saw that he was in Norfolk, Virginia, but he knew he got on the boat in Philadelphia. And so how in the world did he get to Norfolk? He'd been there before. Then the green fog returned, and when it lifted, he's back in Philadelphia. There were a sea level cloud, which formed in the harbor and then began to dissipate. And then the ship vanished. The ship didn't actually quite vanish. What was going on was there's a depression in the water for the ship, but there's no ship there. So this is what's going on. This fog is here. No one knows what the fog is due to, etc. There's a cavity in the water. The men on the ship were apparently able to see one another vaguely, but they couldn't be seen by anyone outside of the field. It was defined by the shape of the hull in the water. And the ship, as we said, became invisible to human eyes. So Tesla was successful in being able to turn something into something that was completely invisible. And as we said, the shape of the keel and the underhull of the ship remained impressed into the ocean water. And, you know, there was another ship beside it, and they were looking in and they couldn't figure out, you know, what's going on. The field effectively extended 100 yards out from each beam of the ship. And so it goes. Now, we're going to go back here and try and give you an explanation for what might have happened here. And there's going to be some incredible leaps of logic here to see. So we have, first of all, this egg of Columbus. We have this egg, this metal egg, and we put it into a magnetic field that has alternating currents. And this generates electrical currents, what are called eddy currents in the egg. They'll generate eddy currents in the salt water around the boat, okay? And this in turn will result in magnetic fields which oppose any changes in this field that we've created here. So Richard Feynman describes it as follows. We have a sheet of a perfect conductor. We put an electromagnet next to it. When we turn on the current in the magnet, currents called eddy currents appear in the sheet, and no magnetic flux enters the sheet. So the same thing happens if we bring a bar magnet near the perfect conductor. So we can suspend a bar magnet in the air above the sheet of the perfect conductor. If the conductor is not quite perfect, there'll be some resistance to the flow of the eddy currents. The currents will tend to die out. The magnet will slowly settle down. The eddy currents in an imperfect conductor need some sort of electromagnetic force to keep them going. And the flux has to keep changing. And the flux of the magnetic field gradually penetrates the conductor. And this results in this thing working. Now, Feynman did all this, but all of this was due to Tesla in 1887. Feynman never acknowledged that Tesla did this. The other thing he does is he plays some games with, the currents that you've got there in the seawater at acoustical frequencies, things at say 1,000 hertz, 3,000 hertz, 500 hertz would end up reacting with the seawater, which is a conductor, and that would make the steam and the mist and the fog. Okay, so that's probably where this came from, was from this field that's generated by the cables around the boat, and so it goes. So now, if we go back to the fact that we could actually put enough energy in there to boil the water, this would ionize the surrounding air, and this by itself would create another field, which would not be a steady mirror image. It would lead to all kinds of distortions and people looking at each other and not being able to see things clearly, which was something that was acknowledged in this experiment. And the water, again, could be heated to the level of steam. The sea would be a heat sink for any heating of the hull, okay? And the end result is this might be what led to the green fog that was around the boat. There was also an acoustic whine and hum that everybody heard. So here's an eyewitness said, I felt a force field against my arm and it was outstretched. There was a pushing or a propelling flow. There were all kinds of sounds that this force field made, a humming, whispering sound, and increased to a sizzling buzz, and so forth. So this shouldn't be surprising. Okay, unfortunately, there were some very bad biological effects of this. Okay, some people saw double, some people started to stagger around like they were drunk. The 200 people on this boat. Some people actually, when the boat moved from Philadelphia to Norfolk and then back to Philadelphia, they became impaled in the steel plates in the walls of the ship. Okay, which was one reason why they quit the experiment. They had no idea what to do. There were people that didn't seem to belong there. It looked like they'd gone to another world and were talking to alien beings. There are all kinds of other visual effects, such as light patterns of stars, wheels, asterisks, all kinds of geometrical shapes. And the intensity seemed to be greatest around 20 to 30 hertz. And above 90 hertz, the phenomenon wasn't nearly as evident. So there's what are called Purkinje figures. Johannes Purkinje was a Czech physiologist who dealt with deceptions of the senses, which he says is how we really perceive things. So illusions call our attention to the workings of the visual system. Normal perception fails to do this. So he had all kinds of crazy things here that led to people seeing all kinds of things. And all of that occurred with the people on this boat. So could it be that as a result of magnetically biasing the ship, that the space itself, space-time, was actually torqued, that there was a deformation of space and time? I mean, how in the world do we explain that the ship disappeared in Philadelphia, appeared in Norfolk, and then made it back again? It's like the two different places were all of a sudden joined together, or torqued or bent, so that they were the same place. And the end result of all this was that you would travel all this distance without actually traveling physically the distance. It just happened instantly. There was no need to traverse the physical distance, because the space itself was warped so that you could get there. There's a notion here of gyromagnetism, and then also this notion of torsion. And the torsion of torquing space itself is probably the thing that did it. We're not sure. And there's a lot of literature since this has occurred, trying to link these things together, the notion of space and time, to what's called quantum mechanical spin. And this leads to two different topics. The most important one is torsion, but they get confused with this other one, which is how you carry out coordinate transformations here. And it's very complicated, so I'm just going to skip over this, but you can look at it to see what's going on. But the torsion really is the key thing that torques the manifold of what we call space and time, to actually crinkle or fold it so that we can reach another point without actually traveling there. And an example would be a towel. You sit there and fold the towel over. So there's these 2 points, one on one part of the towel, one on the other, that touch one another. Voila, I've traversed this distance of the towel without actually physically traveling anything. And the main thing to keep in mind here is this is what Tesla actually saw going on. Einstein was involved because he had similar ideas. He didn't get as far as Tesla. You know, Tesla actually built things, okay, as you saw. And but Einstein was intrigued with some sort of crinkled space-time manifold that would allow you to jump from place to place. And he carried out a lot of different theoretical analyses. There's all kinds of activities here dealing with torsion, with Cartan, who's an incredible mathematician, and Einstein. They had a huge correspondence going on all through the 1920s on torsion, and Einstein was trying to figure out if this would be something that could in fact influence or allow you to travel in space without doing this. And Norbert Wiener, who was a mathematician at MIT, but was also world renowned all through Europe, he recognized that this gave the possibility of having points with different spins and so forth. So there's a lot of indication that there's something like this going on. By no stretch of the imagination are we there. There isn't any meaningful analysis that's been done to date, because the US Navy denies that this ever happened. Irrespective of all these books and interviews of people, that were actually there on this boat and saw these things happening, or were looking at the boat and saw it disappear and then reappear.
Well, of course, they wouldn't want people to know about it if they've actually figured out how to make something that's physical disappear. But I guess my question would be, it's an experiment. It's been since 1945. Have they ever recreated that experiment?
Yeah, it appears that yes, the Black Ops crew has indeed been able to perfect this, and they use it all the time. But that's not, you know, they'll deny that they did anything.
But
Okay.
scientists at MIT, in conjunction with ones in Europe or wherever, haven't tried to do it themselves in an academic
No,
sense.
it's done. What it's done with the Black Ops side of things has a number of bases. So Area 51 is an example of one of these bases, but there's actually a major base in Montauk, Long Island. It's actually a underwater base. It's only supplied by submarines, and that's part of this as well. That has these sorts of things. So there's a lot of evidence that they've been able to perfect this. It's just that they don't want anyone to know about it.
Well, we could just make, you know, a whole fleet go, why not?
Yeah, you know, that you could walk through a door and you know, be on the moon. You could walk through a door and be on Mars, okay? You know, why bother to waste time and money with rockets? You know, and you know, it'd be a lot safer. But so it goes. So the notion.
But talk about some of the fallout,
Well, the fallout.
the guys embedded into the walls of the ship.
Yeah, well, that's because that was the early days and they didn't really understand what they were doing. Okay, they were cognizant of that, and that's why they only apparently did this one time in Philadelphia, but they clearly must have done other things as a follow-up on it. It's just that those aren't public knowledge. This particular thing, you know, there are a lot of people that died that were embedded in the walls of the ship that went crazy from this noise and everything. But it just suggests, again, this linkage between space and time, and how we're just starting to come up on what to do about the real engineering of it, to be able to build something like a gate that could take you anywhere in space and anywhere in time. We can't do it, but there's a suggestion that other people have done it. And so that's why dealing these two different topics tonight, dealing with synchronicity and dealing with this Philadelphia experiment, are in their own ways flip sides of how we're starting to understand how different time is from everything else. And that's the mystery of it.
Such a simple concept.
That's a simple concept. Look, it is what it is, okay? You can, you know, there's a lot of backup material that we'll send out with this, okay? So you can go look at it, but it's you know, just the simple takeaway here is time is different, and we're still trying to come to grips with how different it is. This is the mystery side of science. So next week, we're gonna start to go back. We're still following our curriculum, our syllabus.
Believe it or not.
And we're gonna be going back to Jung now. And
There is a method to the madness.
Yeah.
Is there?
Yeah. Well, and Jung was, I think in many ways, even though he was born in 1875 and he died in 1961, he was really, his time was really for the 21st century. He was just so far ahead of everybody else that, as we'll see, it's that's why we try and spend time on Jung. He simply thinks more deeply about these things than other people do, and it'll stimulate hopefully a dialogue.
Well, he was also just a student of everything, a passionate reader. All
Yeah.
of his life. I mean, you just don't even understand how he had time to sleep.
Yeah, he funded
What
he funded the with the Dead Sea Scrolls, trying to get those translated and put into libraries so that people could access the actual Dead Sea Scrolls. Okay, he's doing this out of his hip pocket. Okay, he funded, you know, the translation of the I Ching by Wilhelm. Okay, he said, no, this is a critical book. We have to dig into it.
They say in the East, they don't really pay any attention to causal relationships because that's self-explanatory. But if you want to really, you know, penetrate anything, you look at synchronicity. That's like a window into universal will or meaning or. But
Yeah, for
they were
thousands
far
of
more
years, the
interested.
Chinese emperors had people in their courts. They were doing this for them. You know, they would, hey, what do we do? We've got this problem. They would, you know, get out their stocks and go at it, and it looks like this is what's going on.
And I think they anticipated the, you know, the invention of the logic behind a computer. Is this binary yes or no, on off code thing, which the I Ching uses this solid line, a straight line, and a broken line
As a, you know, 1 or a 0.
as a 1 or a 0, and then you put, you know, different combinations of on and off or yes and no together. In these permutations, you end up with 64. It's, you know, it's kind of uncanny.
And remember
And
that
it's the
there's
same in the DNA.
yeah, there's 20 basic proteins that you come up with there that go into DNA that can be encompassed by the I Ching, which makes you wonder, maybe the rest of them are still there someplace. Okay, well, 20 is not 64. Where are the other 44? So,
You know, you talk a lot about Carl Jung, and you started off by referencing a bit the collective unconscious. And I always wonder how that corresponds, you know, this to, you know, all these algorithms that are there coded that
well,
Bruce's brother saw. I mean, and how does that compare to, so you have collective unconscious, and then you have other people saying we have multiple lives, and what we're remembering is memory from past lives. But the collective unconscious might be saying really what you're tapping into is just this universal memory.
yeah.
I'm not sure what to make of all that.
Well, the one of the physicists, Stephen Wolfram, has been writing on this and how everything is. He thinks that the most fruitful way to think about this is from the computational point of view of how everything works, but which is again what Ron Cowan saw. Let me go down. Here are these blocks of information here that are Ron saw them as stacked up. This is a wave on one of those blocks that he looked at over here. And here's an example of an electron that happens to be actually a torus. but it's covered with these information blocks. So these things are always scanning, 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 and they contain all the algorithms that govern how the universe works. That's what's going on. And so it's totally distributed, totally parallel, and yet it still all works with one another. One of the reasons why it probably works is because of these extra dimensions. So we have the 10 dimensions here that encompass matter, 4 that are not compactified and 6 that are compactified. We have dark matter, which is right next to us in a separate subspace of 10 dimensions. 4 are not compactified, 6 are compactified, but they're all connected together by this compactified 6-dimensional space, which keeps everything synced up here. All the information is flowing around between these things. And Wolfgang has a whole series of books and papers on this that he's going at right now. And, you know, and we'll see, you know, maybe he's right, maybe he's wrong, but it appears to match what Ron observed, in the sense that there really are some simple rules, algorithmic rules underneath that underlie everything that govern how things work. And you could say that this is the collective unconsciousness. Where would the consciousness be? It's everywhere. It's a complete union of everything, is what's going on here. But, you know, we'll see. That's why we put this class together, was to try and link these things up, and stimulate this sort of thinking. You can take a look on the resources website and you'll see, you know, all of this different stuff here. By the way, another thing to keep in mind with just how the boat disappeared, okay? Remember, here we have this 26-dimensional space here, which is what we're in. Now, we also ended up having these sets of symmetries. There's 20 sets of symmetries here that describe what's going on in the world. But then there's 26 exceptional or sporadic symmetries that don't fall into this general category here. And what this suggests is that each of these dimensions we have here in these 26 dimensions, that there's each of these is linked to one of those other 26 dimension entities that we're talking about here. And just one of those entities has 196,883 dimensions to it. So it could be that the ship simply popped up into one of these extra adjacent dimensions, and that made it invisible, okay?
Go in this dimension.
And the dimensions we're in here, you know, that when you take a
the Calabi-Yau manifold.
Yeah, and here's the Calabi-Yau manifold we're talking about. This is just a 2-dimensional slice of a 6-dimensional. Remember, we have 3 6-dimensional Calabi-Yau manifolds here that we're dealing with, and they're spinning.
So that these could all be like what we think of in science fiction as wormholes.
Yeah,
you know, going into
this is space itself has these holes in it. Okay, so you start to see that there is some structure here, and what happened to that ship is it could have popped into one of these other dimensions, could have popped into one of these holes that we have here that took it off into another dimension. Okay, no one knows what really happened. I'm just asking myself, how could Tesla sit there and stare at this and say, I think I see a way to make the ship invisible? I have no idea what his thought process was to come up with that idea. And he did it clearly in World War I, and he just started to get money for it in the early 1930s.
And then he wanted to stop the experiment. He realized it was potentially dangerous.
Right.
And he was forced to do it anyway, and then dropped out.
Yeah, well, he died. He died in January of 1943. And they went ahead. it's the war, and the mindset was, well, of course we have the ship, so we have to have sailors on the ship. They didn't have to have sailors on the ship. They could have fired the whole thing up without the sailors, but yeah, they put the sailors on the ship. The army did the same thing after World War II ended, and they had these atomic bombs going off. The army said, well, what is our role in the army when we have an atomic bomb going off? So they set off an atomic bomb in Nevada. They had all these soldiers that had to dig foxholes, and after the bomb went off, then they all got up and went charging off toward where the bomb was. Well, they all died of cancer, within 5-10 years. It was the same mindset. We have to have a mission for the Army. We have to have a mission for the Navy. Okay, that's what you're dealing with here. How these people got chewed up. So anyway, that is where we're at for tonight. This is the mystery of it all, of how it comes together, and you can take a look on this resources page here, and here's the whole thing on the I Ching that we put together.
We have the translation of Jung's introduction to the I Ching, which is a fascinating synopsis of his theory of synchronicity. So I think we should send that as an attachment.
I'll send out this I Ching lecture too, so you'll have that. So you'll get some idea of this is probably, in the Chinese mindset, this is probably a better description. The Western science has got it screwed up, except for Tesla. Tesla probably knew what was going on. In fact, one of the things to keep in mind is Tesla, when he was doing this work, he said, oh yeah, there's 2 dimensions to time. Well, I just showed you, Ron Cowan observed that time has 2 dimensions to it. There's a real and an imaginary part to time. Well, how did Tesla know that? I have no idea.
When you put all this together, I mean, we've got our Buddhist here who, thinks about a soul and many lives and moving towards enlightenment and eventually achieving it. And then you have this collective unconscious where everything is available all at once, and you have access to all this information and the entire history of the what does it mean to you? Do you end up feeling, knowing all that you know about quantum mechanics and the major theories and the theology, do you feel like there's a soul that moves through time and space towards enlightenment? Or
no, to me it just means my ignorance is on a higher level.
That's not an answer. Do you think do you think you have a soul that is going to move through lifetimes towards enlightenment?
I do, yeah.
You do that, yeah. With all of this, you still feel there is a soul that's maybe unified with other souls.
Yeah.
But that's assuming the paradigm of time.
Yeah, the soul might
linear.
be.
We don't know that it's linear. I think that's just our way.
You could be living all of this at once.
Right.
You could be living it backwards. Who knows what's going on?
Time could be folded.
Yeah. The reincarnation is a folding where you die and then you get folded over in time to when you're reincarnated. Okay.
I think it's just a way of conceiving of it.
But these are just.
I don't think it is.
Yeah,
literal.
These are words or metaphors.
Right.
They don't begin to describe what's really going on, which is what I think I'm still straining for. Is there's something intrinsically much deeper here that is staring us in the face, and it's an incredible unity, and Bruce can sense
that is the word, the oneness, the unity, even with everything we've talked about and everything I read, you get back to this concept of spirit,
of an order of a
spirit and souls, and that souls are part of the greater spirit, and that there is unity, and that there's an energy in every living thing.
Yeah, in plants, not just in animals, in plants.
Cells.
If it's living, it's got energy, and maybe humans, when you get to the level of being a human soul, that's a little different than being the energy in a plant, but it's still part of this universal, primal, causal, first cause energy.
Yeah, that's what.
And
That's
Andromeda calling.
that's
Yeah. Hello,
and-
God.
But that's all of these different that's why we dropped the word religion and we just said spirituality, okay?
Right.
Is because all of these different religions, again, just to go back to the metaphor of the elephant, where one of them is touching the tusk of the elephant, one's touching the trunk of the elephant, one's touching the ear of the elephant, the tail of the elephant, the leg of the elephant, the side of the elephant, the ear of the elephant. They're missing the point that there's an elephant there.
Right.
But the thing I really appreciate about religions is that they know you can't really talk about it in straightforward linear. They use metaphor because it's more accurate. It's like trying to see something that's representing. It's like those representations of the Calabi-Yau manifold in 2 dimensions. You're trying to represent something with 26 dimensions in 2. It's what a chart, just a graph isn't going to do it. It's going to have to be a poem, that it has a lot of air in it, a lot of space in it for the metaphors. And that's what I like about religions, is I think they know that and they're doing it deliberately.
Yeah, but this is where I think prayer and meditation help, because that takes you to the place where you can start to sense beyond the metaphors and the true reality that's out there that words don't really capture, but you can sense it, and you can sense, the notion of love and compassion and what that really means. But it's a lot of work to go do that, and people don't want to work. So
Well, again, thank you.
that's it for tonight. There's a lot of stuff here, but it doesn't lend itself to
Words.
it's the mystery of time and space, and again, just poking at a piece of the elephant is all we're doing. So
If you can, try to get your hands on a copy of the Jung and Pauli book. I would say that would really be.
well, you can see how they both had incredible intellects, Jung and Pauli, and how the process they went through to come up with this, okay? And yet they were missing, they were missing anything we talked about for general relativity. They were missing anything for dark matter and dark energy. That was enough for them to get them going. So anyway, enough. We will see everybody next week. Have a good weekend.
You too. Bye-bye.
Bye-bye.